Hello everybody, today we're going to be doing another programming problem. Now this programming problem says, you could read it at the top right here. An oil slick occurs when an underwater refinery pipe ruptures, pumping oil into the water. The spilled oil sits on top of the water and causes a natural disaster. For simplicity, suppose that the oil sits on top of the water in the form of a circle. Write a program that prompts the user to enter the rate at which the ruptured pipe pumps oil in gallons per minute, the thickness of the oil on top of the water, and the number of days for which the area is covered by the spilled oil. The program outputs the spilled area in kilometers and the volume of oil in gallons on top of the water after each day. Now, you can all see here, guys, that the first thing we're going to have to do is we're going to have to be doing we're going to have to declare some named constants at the top up here to do some conversions. So we need to write in constant double cubic, actually you need to make these all caps, cubic centimeters in 1 gallon. Now that is the conversion for the amount of cubic centimeters in 1 gallon. Pretty self-explanatory. Now the next thing that we're going to do is we're going to write in constant double we'd write in constant double centimeters in 1 kilometer, which is equal to 100,000. 0.00. And then right here we can write a function prototype and name it oil slick area. We're going to write in double oil thickness, or we could just name it oil thick, comma, double oil release rate, comma, double spill time in hours. Now after writing down this function prototype, we can move on to the main function. Now my idea for the for just pretty much the entire layout of this program is that I am basically going to have this function right here, which will be paired up with a while loop inside of the main function to create a loop that determines the area of the oil slick and the volume of the oil. So first I'm going to write in here, double oil thickness, double oil release, gallons per minute, and int slick days, and double spill area is equal to 0.0. And then you can see out fixed, show point, set precision to 2, semicolon. Now you can see out, enter the oil spill rate per minute in gallons. CIN, oil released gallons per minute, Cout, endo. And then we can see out, enter the oil thickness on top of the water in centimeters. CIN, slick days, Cout, endo. And then we can write in Cout, oh no, sorry, it's actually supposed to be oil thickness. Now this right here is going to be enter the number of days for which you want to know, enter. The area covered by the spilled oil. And then you can write in semicolon, and then CIN, just like it is, Cout, endo. And then you can see out oil slick area after each day for slick days. Endo. After that, we can write in cout, set W, 5, and then square kilometers, so W20, left, in gallons, and no. And then we can just finish it off and do that. Now we can get to writing our for loop. We can write in for int I is equal to 1, semicolon. Actually, hold on. I think I made a mistake here. We're just gonna do that. There we go. And then I is less than or equal to days, semicolon, and each time this for loop repeats, does this. So then we can write in spill area is equal to spill area plus oil slick area, oil thickness, comma, oil released gallons per minute, comma, 60 times 24. There we go. Then we can enter, come right here, and write in cout, set W 4, left, I, you just space 3 times, set W 12, enter, spill area divided by centimeters in 1 kilometer times centimeters in 1 kilometer. So you pretty much just square it, enter, one, two, three. Set precision to 2. And then you write in right, set W 15, oil released in gallons per minute times 60 times 24 times I, and no. Now that is pretty much the end of our int main function. Now we can get to defining the oil slick area function. So we need to come down here and we need to write in double oil slick area. Now we can just write in those parentheses and we'll just copy and paste what's already up here. And paste. And then you can come, open parentheses, and write in double oil volume in gallons, double oil volume in cubic centimeters and double spill area. After that, you can write in oil volume in gallons is equal to oil release rate times spill time in hours. After that, you can write in oil volume in cubic centimeters is equal to oil volume in gallons times cubic centimeters in 1 gallon. And now spill area is equal to oil volume in cubic centimeters divided by oil thickness. And then we can return the spill area. Now we can come and run the program and whoa, okay. I actually forgot to include the header file. IO-man-IP. Now just a quick tip, before running your programs, always check the top of the where the header files usually go, because if you forgot something, and this happens to all of us, let's be real here, you could probably just use something from a header file and you didn't even include it. Just include it and you can run the program and hopefully it runs without error. And when you do run the program, hopefully it should run a little bit like it does here. The oil spill rate was like 84. The oil thickness was, let's say 3 centimeters, and the number of days was covered for 4 days until it was fixed. And that's all the stats you need to know. It tells you the square kilometers and the volume of oil in gallons. After we are done writing the code for this program, I'm going to go over one more time, more or less how this program works. Now right here, we include the header files, pretty simple. Here, we include some named constants in order for us to do our unit conversions a lot easier. So we have the cubic centimeters in 1 gallon, and we have the centimeters in 1 kilometer. Now we have a function right here that will determine the oil slick area in 1 day. Now we can move down here, and you can see that we actually used the oil slick area in coordination with a for loop, and this for loop allows us to determine the amount of gallons of oil and how many kilometers that this oil slick covers for each specified day. Now you can see here we round all of it off to, we set the precision to 2 in this case right here. And here we bring in all of our inputs. We get the oil released in gallons per minute. We get the thickness of the oil on the water, and we have how long the slick lasted. Then we have here oil slick area after each day for how many days. And then we do all of this stuff. We use set W to put that in this. We use the set W to move around and put all of the data in columns. So we place this in the 5th column, which will be more or less in the middle. Now we have the slick area in on the 1st row, and then next we have volume of oil in the 20th column, which is still on the same row. Now we enter, and just so you know, the left actually pretty much means that it's centered towards the left. It's not towards the middle or the right. It's going to be on the left side of your terminal or your screen. Now right here we have volume. Now we're done with 1 row. Now we have set W5, and this is pretty much the same thing. We go into the next row, which we have the day, and then we go to the 20th column left, and we have square kilometers, and then we also go back to the 20th column left in gallons. Simple. And then from there, after we determine the spill area for the specified day, then we print it out in according to the columns and rows that we set up here. Actually, I'm going to pull up the terminal so you can see what I'm sort of trying to get at here, as just telling you isn't enough. So this is what I'm talking about. So we have right here, we have the oil slick for 4 days, right? This is the first column, mind you. See that? Slick area in, slick area in. And then we go a little bit further and we have volume of oil in and out. And then we go on to the next row, and it's pretty much what I already explained. Anyways, you don't have to go over that. Now we're going to go over what's right here. Now the most complicated part of this program is the way that you want to input it in a way that is visually appealing and easily understandable, because you can't just put it in and separate the days, the slick area in kilometers, and the volume of oil, just separating them by commas and call it a day. No, you want it to look nice. You want it to look professional. Now, see right here, we set it to, we put set W4, which places whatever is the day right here. And we also made sure to center it left before typing in any values. Then we space it a little bit and put it in and set W12, giving it this little space right here. Now keep in mind that we made it here so that it will always give us this fixed amount of decimals. It will always give us this fixed amount of decimals. Now we have the volume of oil in gallons, which is right here. And then we print it out, and there we go. We also get trailing zeros, as we wanted it to have fixed values. After we are done going over the loops, we can exit out of that, and I could go over the function once again. Now right here we have to enter the thickness of the oil, the release rate of the oil, and the spill time in hours. Using those three variables, we can calculate the area of the oil slick. So after we take in those three variables, we make three more variables. One of which is the oil volume in gallons, the oil volume in cubic centimeters, and the spill area. And now we have oil volume in gallons is equal to the oil release rate times the spill time in hours. Now, since we're talking about the oil released, we multiply that by the spill time, and we get the volume of the total oil. Now, the oil volume in cubic centimeters is actually the oil volume in gallons times one of our named constants, which is the cubic centimeters in 1 gallon. Next, we have the spill area, which is the last thing which we need from this function, which is equal to the oil volume in cubic centimeters divided by the oil thickness. And then once we're done doing all of these calculations, we return the spill area to get our final answer. Which brings us here, and then we go over here. Now, you may be wondering why in the world, instead of plugging some sort of variable in here, did we plug in 60 times 24? And if you wanted to plug in 60 times 24, why didn't you just plug in 1,440? Now, the reason I put in 60 times 24 is so that it could be a bit easier to understand. Now, you may be looking, and you can see, most of you, that there are 60 minutes in 1 hour and 24 hours in 1 day. This is because we want to find out the number of minutes in 1 day so that we can change it into minutes. Because making everything all in the same units makes everything very, very, very much easier. Now, most of you might also be wondering, why would I plug 60 times 24 in? Now, the reason I would do that instead of plugging in a something that would seem to most people like the correct thing to plug in, like Slick Days. Well, the reason I plugged in 60 times 24 is because, see here, I'm making a loop. Now this loop will calculate the spill area for each individual day. And now, since I'm not exactly working off one variable, like Slick Days, I'm actually working off of constants. Now, this is sort of a little thing that I change up each and every single time that the for loop runs. Now you can also see that I++ means that I goes up by 1 each and every single time that this for loop repeats. And this value, spill area, increases by oil slick area each and every single time this for loop runs. Now, I guess that means that I've pretty much gone over everything that we did in the video all over again. And it means that you probably should already understand everything that we went through. Now, keep in mind this was a fairly complex video that not many of you may understand on the first go. But I hope that you can go over and try and solve this problem on your own. And hopefully, if you solve the problem on your own, you will understand it once again. Because this isn't a very difficult problem, it just takes some critical thinking to understand. Now, I hope you guys have a great time doing C++ on your own, and I'll see you in the next video. Bye!